Okay, in this video we will be looking for how to factor 64x to the 6th minus y to the 6th. So you might first look at this problem and think, hey, this is a difference of squares. I can see that 64x to the 6th has a perfect square of 8x cubed, and y to the 6th has a perfect square of y cubed, so I could factor using difference of squares, and you'd be right. Or you might look at this and say, oh, this is a difference of cubes. I can see I have a perfect cube of 64x to the 6th, which is 4x squared, or I have a perfect cube of y to the 6th, which is y squared, and you would also be right. So we're actually going to look at factoring this both of those ways. Okay? So first, let's do the difference of squares. So as we discussed with the difference of squares, we can see 64x to the 6th has a perfect square of 8x cubed. So I can go 8x cubed minus y to the 6th has a perfect cube of y cubed. So we can see that because, oops, it's not letting me right there. Y cubed times y cubed equals y to the 6th. Because remember, when we're multiplying, we add the exponents when we're multiplying variables. Also, we can see that 8x cubed times 8x cubed would equal 64x to the 6th. So that's why these are the perfect squares, or those are the numbers that times itself equals 64x to the 6th. So we'll have 8x cubed minus y cubed times 8x cubed plus y cubed. Well, now we look at these and we can say, oh, well, these are both perfect cube roots. And so we can factor these using, I know a cubed plus b cubed is going to be the formula if we can remember the signs using SOAP. So same, opposite, always positive. So we have the same, so a plus b, the same as the original. And then it's always going to be a squared, ab, and b squared. So opposite next, so plus, then minus, and then always positive. Okay. Similarly with a cubed minus b cubed, notice it's the same, the variables are the same, a and b, and then a squared, ab, and b squared. So we have the same, so that's minus, opposite, and then always positive. Okay. So using these, we will factor. So the first a is going to be just 2x. So for this 8x cubed minus y cubed, we'll do that one first. So I'll have 2x minus y, and then 2x squared. So I'll have 4x squared, opposite sign, so plus 2xy, and then plus y squared. So there's our first one. Our next one, we're going to have 2x plus y. So we're doing 8x cubed plus y cubed now. So 2x plus y, then we'll have a squared, which is 4x squared, opposite sign, so minus 2xy, and then plus y squared. So we do want to check, make sure nothing can factor further. So 2x minus y, we're good. 2x plus y, we're good. We can see that this one's not going to factor further. So this would be our final answer right here. Now, if we factor, oops, it's not grabbing, there we go. If we factor, let's start with the 64x to the 6th minus y to the 6th. If we factor this again, we should get the same answer whether we have started with difference of squares or whether we start with difference of cubes. Now, difference of squares, in my opinion, is a little bit easier. It's a little bit more straightforward and easier to recognize. But we are going to look at the difference of cubes to see how to recognize this one, or at least how to solve it. So, okay. So if we have this as a difference of cubes, well, this time we're looking what number times itself 3 times would be 64x to the 6th. So I know that 4 times itself 3 times is 64. 4 times 4 is 16 times 4 is 64. And then I know x squared times itself 3 times would be x to the 6th. We can even check and say, okay, if we multiply these, yep, 4 times 4 times 4, we get the 64. And then 2 plus 2 plus 2, we'll get that x to the 6. So 64x to the 6, this would be its perfect cube. Y to the 6 might be a little easier to see. It's just going to be y squared times y squared times y squared. Okay, so we can see it's a difference of cubes, so we'll be using this bottom formula. So we'll do a minus b first. So 4x squared minus y squared. And then we have a squared, so 4x squared squared, which would give us 16x to the 4th. We do an opposite sign here. So we now have 4x squared y squared, and then always positive, so plus y to the 4th. Now looking at this, when I look at it, I can see 4x squared minus y squared. I look pretty quick that that's going to be a difference of squares. So I can see that's going to factor to 2x minus y and 2x plus y. 16x to the 4th plus 4x squared plus y to the 4th. It looks like it should go further, but at first glance, we can't see how it does. We might say, oh, 16 times 1, well, that's 16. There aren't factors of 16 that are going to add up to 4. But one thing that we could try to do is, it looks like it's close to being a perfect square trinomial. And so could we rewrite it so that it is a perfect square trinomial that will add up, that will work out? Because the way that it's written right now, it doesn't. So what if we wrote it as 16x to the 4th and separate this into minus 8x squared y squared plus 4x squared y squared plus 1y to the 4th. Okay, now the reason we're doing this, oops, I wrote that backwards. I meant that to be a plus and that to be a minus because it still needs to add up to 4x squared y squared. So the reason we're doing this is, I'm just going to take this one down further. We'll leave this 2x minus y, 2x plus y just for the end, so we don't have to keep writing that. Put that down here. We'll just go on with this first one. So what I can do then is say, okay, 16x to the 4th plus 8x squared y squared plus y to the 4th. We're going to make this all into 1, and then I'll have minus 4x squared y squared at the end. So what's starting to happen here is we have a perfect square at the end and it's minus. So we're trying to set up another difference of squares. Well, if you look in here now, I have a perfect square trinomial because 16 times 1, so if I'm factoring by the rainbow method, that would give me 16, and factors of 16 do add up to a positive 8. We can see 4 and 4 would add up to 8. And so this would factor to 4x squared plus y squared all squared. Now, if you were just guessing on this, I would definitely come over and multiply it out. Multiply it out and make sure it does indeed work out to be this trinomial. So we multiply that out using FOIL, so we get 16x to the 4th plus 4x squared y squared plus 4x squared y squared plus y to the 4th, and we can see that is going to work out to be 16x to the 4th plus 8x squared y squared plus 1y to the 4th. Okay, so this will factor to 4x squared plus y squared all squared minus 4x squared y squared. Well, now that we've simplified to this point, we can see we have another difference of squares because we have a perfect square with this first term and a perfect square with the second term. So I'm going to switch colors here. So we're going to have for our first term, we'll have 4x squared plus y squared. That stays the same, but that is the perfect square since we have this squared. And then minus, we need the square root of that one, so 2xy. Then the other one will be still 4x squared plus y squared. And if, in fact, if it makes you feel better, you can put it here so that you can see that's the first term. And then now we did minus 2xy, now we need to do plus 2xy. So we can simplify that. We would probably want to write it in the order 4x squared minus 2xy plus y squared and 4x squared plus 2xy plus y squared. Okay, and after all of that, we can see this ended up the same as this one right here. Okay, so we could look actually to see if we could take these further, because we do, whenever you still have something to an even power squared or to the fourth, you want to look if you can take it further. This one doesn't work quite so nicely because we want something, it still has to be factors of 4 because of the 4x squared and y squared. And so we would need it to be either 5 in the middle, or it could be 4 in the middle. But to get 4 in the middle, kind of like we did right here, so plus 8x squared minus 4x squared y squared had to equal that. Well, we could do something like minus 6xy plus 4xy. But that's not, this doesn't add up, and it's not a perfect square, so those are both not interchangeable. Also, xy is not a perfect square. This one worked out because at the end it would still be a perfect square. So anyways, that might have just made it more confusing and maybe not, but now you can see a way to rewrite a trinomial to make it into a perfect square so that it can be factored using difference of squares. So times that you would want to look at this, look at doing this, is when you have an x to the fourth and your middle term is that they both have squared, because then you can rewrite it. That way we were able to rewrite it to have a perfect square at the end, where in this case, we're not going to have a perfect square in the end, okay? But if you hated all of this, you can also just go difference of squares, and it was a lot more straightforward. So one thing you can do if you run into these types of problems, if you run into a problem that could be factored using both a difference of squares and difference of cubes, you could try it both ways just to check that you're getting the same answer, and give the one to go with the way that makes it a little bit more straightforward to get to the most fully developed answer, which in this case would be difference of squares. If you're still confused, please set up a time to meet with me. I know this was kind of a lot, so I'd love to meet with you and practice some more of these, so send me an email.